Good afternoon. This is Dr. Alex Weber-Kamin, and today we're going to be covering the exercise 1 of chapter 7 in Sham Tickoo's Solidworks 2025 for designers. So jumping into this project, we can obviously see that there are several points at which we can take advantage of symmetry. So looking at this shape, you can see it's symmetric about the as drawn vertical axis right now. So we can take advantage of that and only draw half of this shape and then move it across, or I should say mirror it across. And then we can also see that it's actually composed of several different circles for starters. So 1, 2, 3, that one's kind of smaller, and 4 on this shape over here. And what we'll do is create those circles initially. Oops. And then go in and start adding the line work to our drawing. So essentially we're going to create those 4 circles, and then there's this parallel line here that we know is off by 3 degrees from the end of this horizontal line, and it's 5 millimeters off from this outside, this tangent line between the 2 circles. And then things get a little bit weird when we get to this circle up at the top to create the radius, because it's going to be the 50 millimeter one, where we have it running tangent into the end of this line and then coming up to the end where we've got this kind of built up section for the connection. It's going to turn and get turned into a horizontal line, or vertical, I should say. So we're going to go in and start drawing this without further ado. Put up my drawing so I've got it in the background. So we're going to start by drawing on the top plane, because as drawn, we're assuming third angle dimensions, or third angle projection, I should say. We're going to start by drawing our various different lines that we can use for construction. So I'm just dropping one horizontal line here. And then we're going to pick which end of this piece we're going to start drawing from. And for me, I'm going to pick the eye of the right circle. So I'm just kind of throwing in 4 circles to start from. And then we're going to smart dimension from the origin to the third, or I should say second. Let's do third, counting from the right. So we know that one is 125 millimeters from the initial point on the right here. And then from the third, the one that we just dimensioned to, back to the one here, we know that is 100 millimeters. And then going from the very first circle, the origin, to the largest circle out on the far left here, based on the drawing, we know that is 180 millimeters. And then what we're going to do is start throwing in dimensions. So this initial circle is 50 millimeters in diameter. I'm just change that to radius to match the drawing. This one is, those captions are popping up and bothering me, covering everything important. This one is not actually given as a size. We're going to have to calculate it ourselves, which is fine. So what we'll do is delete that dimension and then smart dimension to number 2. And that one we know is 12 millimeters in diameter, or radius 6 as drawn. And then our first circle over here, the inner circle is 22 millimeters. So then we're going to go back over the double circles. So like the one out on the far left and the one on the far right. And I'm just kind of adding those as circles that we'll use in a minute. And just kind of overlaying, I know these are going to be coincident. So I'm taking advantage of having the first one placed so that I can put the second one in on top of it. This one's also listed as a radius. So next up, we've got a line. Actually, before we start doing things tangent, what we're going to do is make it very explicit that the center of this point and the origin are vertically related, or I should say horizontally related. And then we're going to do the same with that circle and the origin horizontal. This circle set and the origin are horizontally related. And then a line sitting on top of our two circles here that we're going to select each of these circles and make them tangent. And I like to set my line offset from the circle that I'm working with in the direction that I'm going to work with it in, because it's a lot easier for me to set up tangency and make sure it's setting it to the correct side if it's set up initially. So I would call this in class priming it. So if I started with this end underneath the circle, it's going to be tangent and it's going to move to about there, but that's the wrong side for this drawing. So I prime SolidWorks to get the solution I want by setting that line on top near where I know the tangent is going to be. So those tangent, and then I'm going to grab that line, offset entities, and it's going to be 5 mm offset, and it's in the other direction than what we're looking at right now. Say OK. And while I've got this selected, I'm going to go in and extend entities just so that I've got these completely connected. So then I know over here, this radius is going to be a fillet of 20 mm, but it's kind of difficult to do a fillet with this circle the way it is right now. So the obvious answer is select the fillet tool. But a slightly less obvious way to do this, and I'm going to show it now, is essentially just using the circle tool. So we know that the circle radius here is going to be 20 mm. So the diameter is 40, setting that as a radius. And then we're going to select this circle and set it so that it's tangent to this line and set it tangent, removing the line there from our relations. There we go. And set those two circles tangent to each other. So what we now effectively have is this arc on the bottom is that fillet that we were going to be selecting. And we don't have to do some pretty major surgery to this end of the piston. And the reason why I'm doing this, creating a second circle up above it instead of creating a fillet, is I want to preserve this contour here whenever we do the next step. So I now have a nice little arc connecting tangent to this circle and tangent to this line. And I can go in and trim off this end and also this end for that matter. And then over on this side, things get a little bit more unusual, let's say. So when we're looking at this end of the device, what we're going to have to do, just for simplicity, I'm going to add a construction line on this side, just so that I've got a nice construction line to work off of. And we're also going to delete this half of the arc just to simplify life a little bit. So hopefully this is beginning to look a lot more familiar to people. I can also, while I'm doing that, trim off the half that we don't actually need. So we're going to have a line from this point to this point. And then going up above that is a little bit more of a strange connection. So we know that there is going to be a line at the top that is 22 millimeters, and it's perfectly horizontal. So grabbing a smart dimension, so. And then the dimensions on this are given on section AA. And it's kind of unusual the way that we've got to work on this, and it's kind of backwards compared to how we normally would work with it. So I'm going to show you how I do this. And I'm selecting this line that I just dropped in there. I'm going to set it as for construction, and I don't really care how long it is right now. We're going to use that as our dimension for the center of this hole, which we're given in section AA as being 74 millimeters center to center. So selected that, select the middle, or correction, horizontal construction line. And then we know that 74 millimeters divided by 2, oops, is about 37 millimeters. And then on top of that, we know that the top line, the one that we just drew with the 22 millimeter line, that center line to the edge is going to be 7.5 millimeters from the 37 line that we just drew, because what we're looking at is going to be the center line being the 37, being that center of our hole, and then the radius of the top of that being 7.5 above that. And then just for now, I'm going to drop a vertical line here. And again, I don't really care about the length, so I'm just going to drop it in there initially and then click it and make it extended. So this is the true troublemaker of this part, where we start looking at the circle, the big radius 50 fillet. So the way I typically go about this one is we know that it's going to be from the center of this third circle vertically, let's say infinite length in construction. And so we're given a dimension that that line is uh, from the center of that circle up 66 millimeters. So I'm adding a line, I'm just going to add it as a construction line and then set a smart dimension on that of 66 millimeters. And then I know I've got a angle of that line where that connection is going to be, and that angle is going to be 3 degrees off from vertical. So I'm grabbing those lines, saying 3 degrees. And while I'm thinking about it, I'm going to set that line as a construction line. And now I'm going to have an intersection point between my 66 degree or 66 millimeter line and my 3 degree line. So I'm going to grab my trim tool and just lop those off. So I know that this connection, this connection is at 3 degrees and 66 millimeters from the center of this circle. So next up, we just drop a center line circle odd knot point. We're going to smart dimension that to the correct size. So we know this is a radius 50 or 100 millimeters in diameter. So what gets a little bit weird about this is we're going to have to go in and say this point, we have a circle that we are intersecting with our 3-degree line here, and we need to figure out where that is going to intersect at. And likewise, we're going to have this connection over here that we're working with and needing to know that intersection. So looking at that, that's not necessarily straightforward. And in fact, there's a bit of discussion that we could have as far as where this connection should be, because this line that we're given over here is given at 3 degrees, and we know that this circle is not given as a size. Oops, take that back. I forgot to put an angle on here. So what we're going to do is Smart Dimension, grab this connection and our horizontal line. Suddenly, this problem just got a lot easier. So now you can see that my circle is fully defined, our lines are fully defined, and Alex is no longer forgetting basic dimensions. And you can see our line here entering this circle is pretty much tangent to the line at the top. This is a good point to discuss that in this case, we would probably want to change the dimensions on this fillet circle slightly so it's not 50.00. It's probably going to be slightly bigger or smaller to make this radius coming into that point tangent instead of just close to tangent. So you can see there's an overlap of that circle and the 3-degree line here. But that's above and beyond my pay grade, and frankly, this is a entry-level SolidWorks class, so we're going to go with what we've got. And I'm just kind of trimming up the corners here to clean up the circles. And we're going to zoom in here and make a decision about where we want to trim this big circle. So I'm going to trim out this connection at the bottom. I'm just grabbing my power trim tool. And then at the top, we definitely don't need that. And we can grab that section like so. And then this is the second part where things get a little bit unusual, because as drawn, we have this radius 50 line coming in, or correction, radius 50 circle or fillet. And then we've got a horizontal or vertical line here coming in. But as drawn, we're going to offset entities to the bottom for 5 millimeters just to make a point. So as drawn in the book, I've got the bottom of my circle shown, the center line of my circle, and then I might as well throw in a top line of my circle just to be complete. So I've got a 10 millimeter hole here. And this fillet coming in, as drawn in the book, there is a hard edge here for a nut or a bolt to connect to. And I think that's a good thing. But the next piece that we're going to add to our puzzle is this part specifies a radius 5 fillet at that connection. So right in here. And as you can see, this is going to cause a curve to begin where it's going to slightly overlap the edge of that hole. So any nuts or bolt heads or something that is sitting on that place is going to be at a small angle, which is not necessarily a good thing, and also kind of lends credence in my mind to the circle, this 50 millimeter circle being slightly different than 50.000 millimeters. It's probably something like 49.999, but we don't have those dimensions to work with, and that's fine. So we now have our part or I should say half of our part. So we're going to grab our mirror entities tool. We're going to grab pretty much everything. Come on. Mirror about. And we're going to grab the center line that we created first. And you can see we've got our lovely mirrored part. And hooray, nothing broke. I know this is a shocking day for everyone in my audience. So we now have the part as drawn. So we're going to grab features, extruded boss base. And what we're going to do, because we know that this dimension is, there are essentially three different heights here. We're going to start with 35 millimeters, and we're going to do midplane. And we're going to select contour, just this circle at the bottom, far left. And then likewise, extrude boss base. We're going to grab the picture-in-picture or absorb sketch number 1. My computer's going to ponder whether it actually wants to behave or not today. And then the far right side is 22 millimeters. We'll grab that contour. Okay. And then extrude boss base again, using the same sketch 1 that we've already used in boss extrude 1 and 2. This one is going to be 15 millimeters. Oops. Contours. And this is where things get a little bit unusual. So we're going to select these contours in the middle. And hopefully I've got a closed shape. I do not, which is fine. So what we're going to do is go back to our sketch number 1. And yours truly forgot to add a line vertically here, which I probably should have had as a hint because I don't have a full gray surface here. So grab a line. Come on, computer. All right, so we now should have a closed surface. I'm kind of wondering if I'm missing a small piece. So we're going to go to extrude boss base, sketch number 1. There we go. And we're going to say that that is 15 millimeters thick. We're going to say, okay. So earlier, whenever we did sketch number 1, we added lines on the end here to make this piece on the right side, or the end here, include the holes as just a measuring part. So what we're going to do is create another sketch on this end, and we're going to actually create our piece that we want to use as a cutting surface now. So as usual, we're going to start by creating a sketch line to work from. And then we're going to create, I know I need 2 circles here. And for that matter, I'm going to create a second vertical construction line so that I've got a nice mirror to work from. Both of them snapped to my origin. And then we also need another circle on the top over our whole circle. And because I've already done this once, I know that I need to add a second rectangle here overlaying the entire piece. And the reason that I'm going to be doing that is whenever I create this surface that we're using as a sketch right now, we're going to use that as a cutting surface. And we're going to do the operation switch edge or switch edge to cut. Probably just botch that. I'll fix it in subtitles. So this hole is on the outside, 37 millimeters or 74 millimeters center to center. And then this circle on the outside is 7.5 times 2. And we're going to switch that to radius because that's what's given in our problem statement. And the inner circle diameter is 10. And then we need a line from the top quadrant point connecting over to our rectangle. Not really sure why it was complaining about a tangent relation being placed in there. All right. And then we're going to go back in and trim the entities that we don't need. So this connection, I'm just using my power trim tool. And then we have exactly half of our drawing. So we're going to grab mirror entities, mirror about the vertical axis, close. And then we're going to use extruded cut in this case. So select contours. And we're going to say flip side to cut. And through all. And see, the reason that I included that rectangle on the top is so that I didn't cut into the connection of the cylinder or whatever shaft we're looking at with this connection. So now we've got our part. Oh, actually, we do not have our part. One last operation. We're going to grab our feature chamfer tool. And we need to go in with a chamfer on the inner circle in here and the inner circle on the top. And we're given that as an angle and a degree. So we're going to say 1 millimeter chamfer, and it's 45 degrees. And then what we're going to do is select these edges, and you can see that I have my tangent propagation tool on. So it propagates across all of the edges that are connecting to that line that I've selected. And then I can say OK. And then voila, we have our lovely piston connection or whatever this part is called. So I hope you have a nice day and see you next time.